Sure, it doesn't erase when I want it to erase. 2.1b, that's a 1. All right, there we go. So, when we're graphing, y equals a sine of b times x minus c plus d is the format of our function. This is the format of our function. A sine of b, x minus c plus d, where a is the amplitude. Amplitude is the stretch or the shrink vertically. B is called the period. That's the stretch or the shrink horizontally. C is called the phase shift. That's the translate left to right. And D is the vertical shift. That's translating it up or down. Okay, so you got to know what A, B, C, and D all do, depending on where things are located. Now, if it's a cosine curve, that's the same as a sine curve, except for it'll have different points, but it's basically the A, B, C, and D affect a cosine curve the same way a sine curve. And it'll affect the secant curve and cosecant curve and tangent curve and cotangent curve the same way it affects the sine curve. Okay? The A, B, C, and D are important. Now, we'll worry about the B later next week. Okay? But we'll worry about the A, C, and D today. If y equals 2 sine of x, what does that affect? Does it affect the amplitude? Yes. The amplitude is twice 2 times as high and 2 times as low. Okay? Does it affect the period? No. Does it affect the phase shift? No. Does it affect the vertical shift? No. So it's just amplitude makes it twice as high, twice as low. Okay. If I had y equals 1/4 cosine of x minus pi over 4 plus 2. Okay. Does it affect the amplitude? Yes. The amplitude, it is 1/4 high and 1/4 as low. Okay. The phase shift, we're moving it pi over 4. And since it happens on the inside of parentheses, it's the opposite of what you think. So when you see a minus pi over 4, you're actually shifting it right pi over 4, not left. So you're going to phase shift is pi over 4 to the right. If it happens on the outside of parentheses, it's what you'd think. So see how this 2 is on the outside of parentheses? It's a vertical shift up by 2. Okay? So that's how the A, B, C, and D affect the graphs. Okay? And we'll talk more about the B, the period, later next week. but we take the easy ones first. All right, let me do something really quick. I'm going to go here. I'm going to go here. There we go. Boom. Like that. All right. Now, we got to know how to graph the sine curve and the cosine curve. So y equals sine of x. Now, I'm going to make every one of these little lines pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, 4 pi over 6, 5 pi over 6, 6 pi over 6, which is pi, 7 pi over 6, 8 pi over 6, 9 pi over 6, which is 3 pi over 2, 10 pi over 6, 11 pi over 6, 12 pi over 6, which is 2 pi. And then I'm going to go, each of these squares is 1/2. So 2 squares will be 1 up, and 2 squares will be 1 down. Now, if you look at your unit circle, what's the sign of 0 radians? What's the sign of 0 radians? What's the y value at 0? 0. So that's the point 0, 0. What's the sign at pi over 6? 1/2. So at pi over 6, we're at 1/2. What's the sign at pi over 3, which is 2 pi over 6? Pi over 3. It's square root of 3 over 2, which is 0.707. What's the sign at pi over 2? 1. What's the sign at 4 pi over 6, which is 2 pi over 3? Square root of 3 over 2, which is 0.707. What's the sign at 5 pi over 6? 1/2. What's the sign at pi? 0. What's the sign at 7 pi over 6? What's the sign at, so then we're to 8 pi over 6, so 4 pi over 3. Negative square root of 3 over 2. What's the sign of 3 pi over 2? Negative 1. And then we get negative 0.70, whatever, negative 1/2, 0. So it makes a curve like this. That's y equals sine of x. Now, when we graph these, we're not going to have to graph every single point every time. I'm going to understand that you know what you're doing, and that we'll just make a nice smooth curve through certain points. Okay. Now let's look at y equals the cosine of x. We'll do the same type of thing. Now going every 3 to get to pi over 2 is really nice on a piece of graph paper because it kind of hits all the points we need to hit. And actually, if we'd go 12, that would be perfect because then we would definitely have a line for every point we want to hit. Because when we had to do pi over 4, it's halfway in between these two, so it would be right there. So when we hit pi over 4 for certain graphs, you have to figure this out. But it's not too bad most of the time. All right, what is the cosine of 0? And don't say 0. Cosine of 0 is 1. We're going to skip all the way to the cosine of pi over 2. What's cosine of pi over 2? 0. What's cosine at pi? -1. What's cosine of 3 pi over 2? 0. What's cosine of 2 pi? 1. The graph is not this. Don't ever do this. You do that, I count it wrong. Graph is not like that. What was it like here? It was a curve. If we would graph every point down here, it'll be a curve. Now, don't go like that and go like that. That is wrong because it keeps going as a curve in both directions. We just graph normally from here to here, we graph one period of the graph. A period is how long it takes until it repeats. Okay? So it goes from here to here, and then it starts repeating. For the sine curve, it goes from here to here, and then it starts repeating because the next point will be right here, and then here, and then here, and then here. So then it repeats itself. So generally, we do one cycle until it repeats. That's a period. When we're doing tangent and cotangent, we'll do two of them because that's just what we do. Okay? So if you were told to graph y equals 2 sine of x minus 1. Okay? What are we affecting? The A, the B, the C, the D, or a combination of a couple of them? Which two are we doing? A and D. C is inside the parentheses. It's A and D we're affecting. So everything we're affecting is vertical on this. Okay? So what we're going to do and what I will request you to do, and you have till Tuesday to do it, is get some colored pencils and put them in your backpack. Some of you already have colored pencils or colored pens in your backpack. But get some colored pencils or colored pens in your backpack because we're going to do these in several colors and we're going to put graphs on top of each other to show what we go from step to step to step. So I'm going to graph the y equals the sine of x first. And then I'm going to graph y equals 2 sine of x. And then I'm going to graph y equals 2 sine of x minus 1. So I'm going to lay out my graph. And in light blue, I'm going to graph y equals sine of x. So, in light blue, I'm going to graph sine of x starts at 0, 0. At pi over 2, it's 1. Pi, it's 0. 3 pi over 2, -1. 2 pi, it's 0. You will remember this after we do it enough. Okay, that's what the sine curve looks like. That's what one period of the sine curve looks like. Okay. Now, if I want to graph y equals 2 sine of x in green, what I have to do is I have to make sure I have 2 and -2 on my graph. Now, 2 sine of x is a stretch. When you stretch 0, where does it stretch to? 0. It doesn't stretch. 2 times 0 is 0. So it starts right here. What's 2 times 1? 2. So it stretches up here. So it has a y value of 2. Or if it has a y value of 1 originally, it'll have a y value of 2. If it has a y value of 1/2, then it'll have a y value of 1, and so on. So if it has a y value of 0, 2 times 0 is 0. If it has a y value of -1, then we go -2. Okay, there's one period of y equals 2 sine of x. Now I have to graph in red y equals 2 sine of x minus 1. So I take the green graph and I'm going to translate it. I'm not going to stretch it. I'm going to translate it. Every point goes down by 1, down by 1, down by 1, down by 1, down by 1. So now we're at -3. Ta-da. Okay? Now we're going to answer some questions. Okay? What is the amplitude of this graph? An amplitude is the absolute value of the high minus the low divided by 2. The high minus the low divided by 2. So 1 minus a -3 is what? What's 1 minus -3? -4. What's the absolute value of -4? Wait, no. 1 minus -3 is 4. What's the absolute value of 4? 4 divided by 2 is 2. So its amplitude is 2. Its amplitude is 2. All right. What is its period? How far did I graph until I repeated it? Well, I went to 2 pi. Yes, young lady.
For amplitude, do you always have to do that high and low, or can you just look at the equation?
You can just look at it and figure it out. Okay, the period is 2 pi. Okay. The phase shift. What moves my phase shift, right or left? None. I didn't shift my original graph right or left. I left it where it was. Okay. What is my range? What's my lowest point to my highest point? What's my lowest point? -3. What's my highest point of my final graph? 1. Okay. So these are some of the questions you will have to answer after you graph it. Okay. So even if it doesn't tell you to graph it, I want you to graph it. Okay. So there will be some that you'll have to graph. All right. Let's do another one. Let's graph y equals negative cosine of x minus pi over 3. Y equals negative cosine of x minus pi over 3. Well, what's my base root function here? Y equals cosine of x. Just cosine of x is my base function. Then what I'm going to graph is y equals negative cosine of x after I graph my original cosine of x. Then I'm going to graph negative cosine of x. And then, because I want to work from left to right, I'm going to do this first. And then I'm going to phase shift everything negative pi over 3. So I go 3 to get to pi over 2. I go 3 more to get to pi. 3 more to get to 3 pi over 2. 3 more to get to 2 pi. Uno, negativo uno. Okay, where does the cosine curve start? 0, 1. 0, 1. Then I go pi over 2, 0. Pi, negative 1. 3 pi over 2, 0. 2 pi, 1. And do not go like this. You go like this. I count it wrong. It's like this. Know that it goes back down again after you hit that. Okay? So, negativo cosine. Instead of being at 1, I'd be at negative 1. 0, 0. Negative 1 goes to 1. 0. Negative 1. When you do the negative and the positive on the same graph, it looks like DNA. Now, minus pi over 3. If it's inside parentheses, you move to the opposite of what you'd think. Instead of going minus pi over 3, instead of going to the left, you're going to go to the right. Now, how many squares to the right am I going to go? Well, let's figure this out. If pi is 6 squares, I'm going pi over 3, which is 1/3 of pi. What's 1/3 of 6 squares? 2 squares. So I go 2 squares to the right. So I take the red one and go 2 squares to the right. 2 squares to the right. Stand up, sit down, fight, fight, fight. Okay, I'm not a cheerleader. All right. So the green one goes like this. And so my final answer will be my green one. And thus is why we have colored pencils in here in the future, or colored pens, or whatever. Okay? Because then you can tell which graph is which. Now, if you only have a pencil or a pen, or a pencil and a pen, you can do one of them dashed line and one of them with certain marks on it and however, but it's a lot nicer if you have colored pens and pencils. All right, so for this one, what's my amplitude? Amplitude, you take the absolute value. It's 1, okay? Always going to be positive for amplitude because it goes from the original point, it goes up 1, down 1. So 1 is the amplitude, okay? Period. Well, today's period will always be 2 pi. Period is always going to be 2 pi today for the answer, okay? Phase shift. How far did I move in which direction? Pi over 3 to the right. Okay, tell me how far in radians and tell me which direction. And then the range, lowest to highest. What'd I do? -1 to +1. Do you want to hear me talk more or you think you got it? Got it? Okay. So, over here, there is graph paper in the box, the back box, scratch paper, graph paper. So if you want to get graph paper, you can. If you want to do it in your notebook, you can. I do not care. Okay? But you gotta you're gonna be graphing, so it's however you want to do it. Your problems will appear on page number 117. We're going to do 57 through 69, the odds. 57 through 69, the odds. And then when we come back next Tuesday, we're going to spend one more lesson on this section. We're going to graph a little bit more just to get this down better. Okay? On 57, 59, and 61, it doesn't tell you to graph. I want you to graph them. I want you to graph those three. It just asks for the amplitude, phase shift, and so on. I want you to graph them as well. Yeah. All right. So